Hello, we are discussing about GATE 2006 ECE paper. In the two-port network shown in the figure, find Z12 and Z21. Any two-port network, okay, a two-port network, as the name implies, it will be consisting of two ports, and either port can be used as input as well as output. So this is a simple two-port network, and port 1 is having two parameters, voltage across that one and current flowing through it, indicated as V1 and I1. Similarly, port 2 can be represented with parameters of port 2, voltage across that one as V2 and current flowing through port 2 as I2. So every two-port network will be consisting of four parameters, V1 I1, V2 I2. Out of those four parameters, two will be treated as independent, two will be treated as dependent parameters. Okay. So which parameters will be treated as dependent? That will be making. Okay. By that time, other two parameters will be independent. One parameter at a time can be either act as independent or dependent. Okay. At a time, it cannot act as both. So that if you choose two parameters from that one, from the four, as independent, the other two definitely act as dependent. So if you choose V1 and V2 as dependent parameters, V1 and V2 as dependent parameters which depends on I1 and I2. So I1, I2 are going to be treated as independent parameters. If V1, V2 are dependent, I1, I2 are independent, then the parameters results are Z parameters. Okay, and Z parameters are indicated with Z11, Z12, Z21, Z22. How they calculate is also given. Z11 is V1 by I1 at I2 is equal to 0. Z12, Z21, Z22. We are going to calculate Z12 and Z21. So for the given circuit, you are going to write the expressions. Okay. And from that expressions, you are going to obtain Z11 and Z12. First, we will identify the port. Okay. So this is port 1. So voltage across this one as V1, current flowing through this one is I1. Voltage across this one is V2, current flowing through this one is I2. First one is V1 can be written as V1, voltage across this RE resistor. So it can be written as I1 times of RE. Okay. From Z parameters, the general expressions can be written as from this one. You can write V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So now here we don't have any I2 term, so you can write as something as 0 into I2. Okay. So if you compare this equation with this one, then from this one you can get the values as Z11 is equal to RE and Z12 is equal to 0. And next equation, okay, next one is apply KCL across this point, or V2 can be written as, okay, directly you can write V2 is equal to, this is a independent current source in parallel with a resistance. Okay, this can be replaced by using source transformation technique. If you use source transformation technique, then a current source in parallel with resistance can be represented equivalently with a voltage source in series with the resistance. Whether plus minus is depending on the arrow direction. Arrow direction indicates plus, tail indicates minus sign. So this is the equivalent resistance equivalent circuit. By using source transformation between these two terminals, the two terminals is giving the voltage V2, and resistance will be same R0. Voltage is nothing but multiplication of current into resistance. So this is beta times of I1 into R0. Okay. So V2, now you can write from this one, V2 is equal to minus beta times of R0 into I1. Okay, and here also you are not getting any I2 term, so you can write it as 0 into I2. 0 into I2. So from this one you can get this one, you can write by comparing this V2 equation with this one. V2 is Z21 is equal to minus beta times of R0 and Z22 is equal to 0. Okay. So here we are going to calculate Z12 and Z21. Z12 is 0 and Z21 is minus beta times of R0. So the right option for this one is B, 0 and minus beta times of R0.